In this video, we're going to start talking about concepts in Chapter 2, which Chapter 2 is called Rate of Change. And we're going to be particularly replacing the word rate of change with what we call the derivative. And we're going to talk about what the derivative is, what the derivative function is, all the things of that nature. We're going to start in this video with what we call instantaneous rate of change. And so that is the goal of this and the next couple of videos. Instantaneous rate of change. Well, before we get there, we're going to review average rate of change, which we already defined. It says if y is a function of t, that means we can write y equals f of t, then the average rate of change of y between t equals a and t equals b is given by the following. And remember, when we were dealing with average rate of change, the purpose of dealing with average rate of change is, unlike linear functions, when we have functions that are nonlinear, if we want to talk about average rate of change, we can kind of use the slope of the secant line to help us get that. And so we had this diagram that looks something like this, where I have my function f of x in blue here, and I'm going to try to calculate the rate of change or estimate how this function is changing. Well, it changes differently depending on where I'm at in the location of the function. And so because of that, we have to specify some values in our domain, let's say between a and b. And what we'll do is we'll kind of use the slope of the secant line in order to help us come up with the average rate of change. And so this black line here is, remember, what we call the secant line, and the slope of the secant line was the average rate of change. Okay, so on average, whatever this value of the slope of this line is, let's say the slope was 1.5, then on average between x equals a and x equals b, I know this function was changing at a rate of 1.5 units of y per unit of x. Okay, now of course this is given in function notation, and so if I'll go back to this little piece here of writing the formula for average rate of change, here we have y as our output and t is our input, and t is going from a to b. At one point we said average rate of change is f of x2 minus f of x1 all over x2 minus x1. Well, here we have a and b as our x's. Let's say a is our first x and b is our second x. Then our average rate of change will be f of b minus f of a all over b minus a, right? And remember, that is your average rate of change, which is on your graph, your estimate of slope of your function, but it's non-linear, so it's an average, right? But it's the exact slope of your tangent line if your tangent line goes through the point where your x or your t equals a and your t equals b. And I said tangent line, we're going to actually get to there later. I meant to say secant line. Okay, the units of your average rate of change is, well, since we do your f of b minus f of a, and f is your y or your output variable, so we're going to have our units of our output variable, which is y, divided by or per unit of my input variable, and in this case our input variable was t. And so that was average rate of change, and we did that because unlike linear equations that have a constant rate of change, nonlinear functions have rate of changes that depends on the locations, and we'll be able to calculate that or estimate it using our average rate of change. Okay? Well, now we want to talk about instantaneous rate of change, and this is the goal of this section here. Okay? So instead of, like, you know, if I had a line and I wanted to know the instantaneous rate of change, well, no matter what point I'm at on this line, my rate of change is going to be exactly the same, right? It's always my slope. My slope is constant over all these lines right here, right? Or that's only one line, but you get what I'm saying. If I have a curve that looks something like this, then my rate of change of my function at this point right here is going to be totally different from my rate of change of this point right here. And we want to be able to find out what the actual rate of change is at that point, okay? And so instantaneous rate of change is at an instant. Look at the root word there, instant. So it's at a specific point, right? We want to know the average of the rate of change at a specific point or value in your domain, right? And so the instantaneous rate of change of f at a, also called the rate of change of f at a, is defined to be the average rate of change over shorter and shorter intervals around A. And so what I'm going to do is I'm going to look at a picture of this. Let's say that I have a value A. And my goal is for this function, which we'll call f of x, is to find the instantaneous rate of change at A, right? I want to know exactly how my function is changing at that point. Then what I'm going to have to do is I'm going to have to go through the process of calculating the average rate of change around A, but I'm going to do it for certain intervals that get smaller and smaller and smaller. And by what I mean, let's say I pick a value, I'm going to use a different color here. Let's say I pick a value, well, that's too big, B, and I'm going to give it a sub 1, right? And I would calculate the average rate of change from A to B1, right? Let's see, my function continues like this, and B1 is up here, the functional value, right? Well, my average rate of change from A to B1 would be f of B1 minus f of A all over B1 minus A, okay? And that value, and this is going to get a little tricky because it's hard to draw on this, is the slope of that tangent line, right? Of that secant line. This green is secant line. Okay? That is average rate of change, right? So instantaneous rate of change kind of uses average rate of change. But what I mean by this over shorter and shorter intervals around A is that, hey, if I pick another value of B that's closer to A, let's call it B2 here, I'll go up to my function, I'll find out where my function has a x-coordinate of B2 and a y-coordinate or whatever on my function, and I can find my average rate of change from A to B2, right? Which is f of B2 minus f of A all over B2 minus A, right? And what I can do is what I did before is I can find, draw my secant line, and my average rate of change will be that slope of this blue secant line. Okay? And then I can pick another B. Let's say, well, I'm running out of colors here. Let's say I used this color right here. Let's say I picked the B3. This is getting tight, which is very, very close. All right, so now I'm doing an even shorter interval around A or by A, right? I want to calculate my average rate of change. Now I'm going from A to B3. That'll be f of B3 minus f of A all over B3 minus A. And so if I drew my secant line that passes through those points there, I may get something like that. And if I continue to go and get a B4, a B5, a B6, do average rate of change, I'll eventually get to the point where the distances between A and one of these B's is so close that it's basically right on top of A, x equals A. And so what is going to happen is I'm going to basically have what we call a line that just touches the graph at A, but doesn't really intersect it. And my instantaneous rate of change is actually going to be the slope of this line. And this line is called your tangent line. Okay? And so instantaneous rate of change of f at A, also called the rate of change of f at A, is defined to be the average rate of change of f over shorter and shorter intervals around A, to the point that we get to what we call a tangent line, which is a line that a graph that touches a graph but doesn't cross at more than one point. And we're going to continue with this next video.